Assalamualaikum and a very good evening to Dr. Musab. So today we are from Group 11 and we're going to present on our project on the consequences analysis of ethylene steam cracking process using ALOHA software, which is the release of propylene gas. So firstly, uh, I'm going to present on my group members, which is firstly Muhammad Aliff Ikhmal bin Zulkafli, and then me myself, Muhammad Arash bin Yusrannadzirin, and then Ahmad Saidi Shuib bin Ahmad Latfi, and lastly is Nur Sabrina Binti Muhammad Nur. So our objective of the study is to evaluate and analyze the consequences analysis based on the difference of wind speed, which is 5 meter per hour, 10 meter per hour, and 15 meter per hour. So towards type of tank failure using ALOHA software. And the first scenario we're going to combine is the leaking tank, which is chemical is not burning as it escapes into the atmosphere. Then the next scenario will be a leaking tank, which is the chemical is burning as a jet fire. And then lastly is BLEVE, which tank explodes and chemical burns in a fireball. And then the next objective is to highlight and propose the recommendation for mitigation measures and emergency response plan based on the findings. So as the result and also the discussion, I'm going to explain on the first scenario, which is 5 meter per hour with a leaking tank, which is chemical is not burning. And so we can see from the diagram here is which has a concentration of 1500 ppm is on the yellow zone, which has a radius of 882 meters from the source. And then we can see from the orange zone, the propylene concentration exposed is 2800 ppm, which is in a radius of 643 meters. And then the people who live around 260 meters from the source is in the red zone, which has a greater dangerous consequence with the concentration of 17,000 ppm. For the leaking tank, which the chemical is burning as a jet fire, we can conclude from this diagram that the people who live around 65 meters can really feel the pain within 60 seconds, which is in the yellow zone. And then the next zone is the orange zone. We can see here that within 16 seconds, we can feel the second degree of burn when we are exposed in this orange zone, which is known as a second degree, and with the radius of 41 meters. And that is quite not far away from the people who live around. And then the next one is the red zone that is only 29 meters from the ignition source, which is so dangerous to the people who live nearby and can cause potential fatality within just 60 seconds. And then the last one will be the scenario on 5 meter per hour with BLVE tank failure. And then we can see on the first zone with a radius of 2 kilometers from the tank, the yellow zone can really have the the most area affected by the explosion, that it can cause pain within just 16 seconds. And then we can see from the orange zone, um, it can cause second degree burns within 60 seconds with the people who live in the radius of 1.3 kilometers. And then lastly, um, the potentially lethal if there is no immediate treatment within 1 hour after the incident can be caused when the people who live or work nearby around the areas of 0.904 from the leakage.
So for the second scenario, which is wind speed 10 mph in leaky tank but the chemical is not burning, just escape to atmosphere, we can see from the map the propelling exposed around the southern from the leaky tank. For yellow zone has a radius 4083 meters with 1500 ppm. Orange zone has a bigger concentration exposed with 2800 ppm in radius 3035 meters. For red zone, it has a greater consequences to people live around 1070 meters from the leaking tank because it has concentration above 70,000 ppm. When leaking tank occur, the propellant is burning as a jet fire cause the area exposed is circled in map. This just happened in around leaking tank. Yellow zone with a radius 65 meters can cause a pain within 60 seconds from the leaking tank. Orange zone, or known as a second degree burn, has a radius 43 meters, and for the red zone, just 30 meters from the leaking tank, and this can cause the potential fatality or serious injury in 60 seconds. For BLEVE, the area affected is very bigger and many people live and working around the area. For the yellow zone, this can cause a pain in 60 seconds with 2 kilometers radius. The orange trade zone has a radius 1.3 km, while for the red zone, people live or working around 0.904 km from the leakage sources can cause the potentially lethal. For third scenario, which is wind speed 50 mph, in leaking tank but the chemical is not burning, just escape to atmosphere. The propellant exposed around the southern from the leaking tank. For yellow zone has a radius 3084 meters with 1500 ppm. Orange zone has a bigger concentration exposed with 2800 ppm in radius 260 meters. For yellow zone, it has a greater consequences to people live around 86 meters from the leaking tank because it has a concentration above 17,000 ppm. When leaking tank occurs, the propellant is burned just as a jet fire because the area exposed is circled the area around the leaking tank. Yellow zone with a radius 66 meters can cause the pain within 60 seconds from the leaking tank. Orange zone, or known as a second degree burn, has a radius 43 meters from the leaking tank. Red zone just 31 meters from the leaking tank, and this can cause the potential fatality or serious injury in 60 seconds. For BLEVE, the area affected is very bigger and many people will get affected if the explosion occur. For the yellow zone, this can cause the pain in 60 seconds with 2 kilometers radius. The orange trade zone has a radius 1.3 km, while for the red zone, people live or working around the 0.904 km. For the leakage sources can cause the potentially lethal.
Bismillahirrahmanirrahim. So next I will be presenting to you about comparison between accuracy of result, theory and limitation of theory. So although it is known that ALOHA software has the ability to work simulation for different situations, it is admitted that there are some technical weaknesses that need to be known. Even with the best possible input values, in some cases, ALOHA can be inconsistent and it cannot model certain kinds of releases at all. In fact, ALOHA's concentration estimate can be less accurate when any condition exists that reduce mixing in the atmosphere. So for the first part, the contaminant cloud does not mix easily with the surrounding air at very low speed than 3 to 5 mph. In the chemical cloud, the gas concentration can constantly be higher than ALOHA predicts, especially near the source. In this project case, an assumption is made that the ALOHA simulation achieved by setting up the wind speed at 5 mph is not highly accurate due to low wind speed. In the future, another project should be assigned for bigger wind speed to achieve better accuracy and precision. So next, ALOHA assumes that in the region downwind of a chemical spill, wind speed and direction are constant. Besides, the observed facility placement for this project is in an industrial area in Kerteh, where there are many different types of buildings and heights. So next, I will be presenting to you about comparison with literature. Earlier, a simulation investigation production of propylene was conducted by several Chinese researchers at their one of the largest industrial sites in West China, Qingyang. One of the researchers explained that the purpose of the research was to design the daily safety management supervision that focuses on mitigation of unpredictable weather that could be the initial factors. So as you can see, both graph is the comparison of trade zone between propylene production facility at Kerteh at the left side and Kenyang at the right side at 15 MPH. So this is the result gained from our investigation and another researcher's investigation. In Kerteh, with the influence of wind direction, the concentration of propylene in the range of only 86 meter for greater than 17,000 ppm. But for Kenya, the radius or the red zone is a lot more than the Kerteh, which is 199, almost 200 meter for greater than 70,000 ppm. So next for the orange zone, it is detected that around 86 to 260 meter for greater than 2,800 ppm. While for the Kenya, it is from almost 200 to 503 for greater than 2,800 ppm. So for the radius or yellow zone, 320 meter for greater than 1,500 ppm in Kerteh, but for the Kenya is much far away, 690 meter for greater than 1,500 ppm. So the different results between the two places are due to the difference of elevation from the sea where Kerteh only 12.8 meters, but for the Kenya is 1,398 meters, as I said before. Besides, the measurement height also varied for both places. Higher places result in more time allocated for vapor cloud move to the affected area with constant wind speed. If the wind speed keep changing, people who are at greater distance than the ALOHA software reading, in this context, those who are in safe position need to be vigilant at any cost.
Based on the simulation conducted, we are proposing three types of control in order to reduce the impact of the consequences. The first one is engineering control, where it is recommended that there should be installation of detection system, or we call it a sensor, relief valve, blow down drum, and also inert gas system. Sensor is important to detect any uncommon reading of wind speed. Relief valve is to reduce the possibility of leakage. Blow down drum helps whenever there is abnormal operating condition, and then the chemicals inside the tank will be pumped into the underground safe area. And lastly, for the inert gas system, it is important as it helps to lower down the oxygen concentration inside the tank. Moving on to administrative control, it is important for the management to ensure that standard operating procedure SOP are implemented at all times. Also, employees should be exposed and should go to training, workplace training, especially on SOP and emergency responses. This is important as they will know what to do whenever any incident happens in the future. It is also important for the facility to establish and maintain good housekeeping. This includes having scheduled inventory control, where this can help to prevent any storing for such a long time. The management should also introduce a permit system where only qualified personnel are allowed to access to certain areas or to handle certain specific chemicals. Not only it is important to control on the facilities only, but it is also important to educate the local authorities, the communities around them. So this is where the distribution of information on risks and hazards are important to the community. This includes involving them in scheduled drills so that they also will know what will happen in case of any incidents that happen in the future. And lastly, for the personal protective equipment PPE, as we are working with a lot of foreign substances, it is important to wash our hands regularly. And then of course, we need to avoid it. It is best to avoid touching our eyes, nose, and lips. And then self-contained breathing apparatus is important as well, and it is need to be accessible at almost all places. And then it is vital for the employees to use fireproof coverall, shield, gloves, and conductive. especially for those working in the fire hazard processes. And lastly, fire extinguishers and fire blankets are must be accessible at almost everywhere in the facility, especially in the areas that are connecting with high fire hazard. We have come to the end of our presentation, so we're going to conclude the project that we have conducted. In conclusion, wind speed at 15 miles per hour is the most dangerous one since propylene gas can spread faster due to higher speed compared to 5 and 10 miles per hour. This applies especially for the simulation of leaking tank chemical is burning as a jet fire. However, this simulation alone does not portray the real-life situation, as there might be some issues on topographical and building effects. Most industrial sites from which gas dispersion will contain a number of building vessels, pipelines, etc. As this building varies in height, it will significantly affect the airflow at levels of interest, where this will interrupt the wind speed. However, ALOHA software is a good software as it allows conducting the scientific research work expanded up to the analysis of domino effects for the critical infrastructures, risk assessment, and working out the actions on management of the risk. That's all from our group. We hope that you understand the presentation. Thank you.